All right, so this is the last section of the measurement unit. And I'm recording a video for you because this section contains some material that is new to this course, the MGF 1130. So this gives us also an opportunity to review some things. So first, we're going to talk about measuring weight. And in the US system or the English system, which we are used to in the United States, we have several units for weight, ounces, pounds, and tons. And so we're just going to practice a super straightforward unit conversion. We're going to convert 192 ounces to pounds. So this is great. Good review for us. So we're going to start off with our 192 ounces, and then we are going to multiply by the unit conversion. And so the conversion here is a one-step conversion. We have the relationship between ounces and pounds. 16 ounces is 1 pound. And so then the question you're always asking yourself in all of these units when we do some dimensional analysis and we change units is where am I going to put each unit? And so my goal is to get rid of the ounces and have pounds. So I'm going to put the 16 ounces down here and the 1 pound up here. That way, what happens is that cancels. I love dimensional analysis because I don't have to worry about whether I multiply or divide. This tells me I'm going to take the 192 and I'm going to divide by the 16 because it is in the denominator. I take out my good buddy, the calculator. I'm going to turn it on here, and what I get when I take 192 and I divide by 16, we get 12. Okay, so we have 12, and that is 12 pounds. The basic unit in metric system for weight is the gram. And so again, we are just doing a little bit of review here. So I'm just going to give you a few seconds for exercise 2 and exercise 3. What I'd like you to do is pause the video and remember your metric conversions, and then push play on the video. All right, so welcome back. So what we're going to do is we're going to convert 8.7 decagrams to milligrams. And so remember, metric system is all base 10. So I am going to just take my, I'm going to start at deca, and I am going to go this way with my decimal places. I'm going 1, 2, 3, 4 hops to the right. So that means that I'm going to take this decimal in 8.7. So I'm going to rewrite it right here so I have a little more room. And I'm going to move it 1, 2, 3, 4. And so that means I'm going to add in 1, 2, 3 zeros. So 3 zeros. So that's 87,000 milligrams right there. So hopefully you did the same thing, centigrams to grams. So in this case, going from centigrams to grams, we're moving the decimal 2 places to the left. So in my 950, the decimal's assumed here, 2 places to the left. That is going to be 9.5 grams. Okay, so that is our basic conversions. Now, in the metric system, in the way it's designed, there is a very interesting relationship between volume and weight, and one of the most basic molecules, which is water. Okay, so volume, weight, and water. This doesn't apply to just any liquid. It's only water. But notice 1 centimeter cubed, which we know is 1 milliliter. We saw that conversion. We've seen that conversion before. But with water, that's also equal to 1 gram. It's very convenient for conversion. 1 decimeter cubed, which we know we've seen this conversion before, is 1 liter. That is equal to a kilogram of water. Again, notice all the ones. Very straightforward relationship. So 1 meter cubed, which again, we've seen this conversion, is a kiloliter. That is 1,000 kilograms, or 1 metric ton of water. So if an aquarium holds 0.75 cubic meters of water, how much does the water weigh? So this is cubic meters. And so I've got 0.75 meters cubed. What I would like you to do, again, push pause on your screen, is I would like you to convert using this table right here. Meters cubed into a weight. Okay, welcome back to the video. We are now going to multiply by our unit conversion. And right here, meters cubed is equal to, we'll say 1,000 kilograms. And so that is 1 meter cubed is equal to 1,000 kilograms. And so I am going to now cross out the meters cubed. That's why I put the meters cubed in the bottom to cancel. And so now 0.75 times 1,000. You need to go to your good buddy, the calculator, and a 0.75 times 1,000 is going to turn out to be 750. So we have 750 kilograms of water. All right, so everything on this front page, the process has been review. We've just been doing dimensional analysis in a couple problems, and we've been converting metric units in a couple problems. While we're talking about weight, there's not really anything new. So again, same thing for the first couple problems in the top. Now we're going to convert between English and metric units. So what I would like you to do is, again, push pause on your video, and I would like you to do exercise 5 and exercise 6. Use this table to perform these conversions. All right, welcome back. I hope you took the time to do that. I hope you're not just waiting for me to do it, because that's not learning. Okay, learning is when you're actually doing the work and having to make decisions. That creates neural pathways and helps you remember things. So if you did not do the problems, if you're waiting for me, push pause, do the problems. That is going to be way better for you than watching me. So here we go. I'm going to convert 120 pounds to kilograms. So I'm going to start with my 120 pounds. I'm going to now multiply by my unit conversion. And this is a 1-to-1 unit conversion, very straightforward. We don't have to do this twice. And so I have 1 pound is 0.45 kilograms. So again, since I want to cancel the pounds, I'm going to put the 1 pound in the bottom, and that's 0.45 kilograms. And so there we go. It's a straightforward, my pounds cancel. I'm now going to multiply. That's what the dimensional analysis tells me. Okay, so I'm going to take 120 and I'm going to multiply it by 0.45. And when I do that, I get 54. So the result is 54 kilograms is what we're all looking at. Okay, the next one, we're going to use that same table, and we are going to convert 100 grams to ounces. So I'm starting off with 100 grams. I'm going to multiply by my unit conversion. Again, this is a straight 1-to-1 conversion between ounces and grams that we're given. And again, I want to cancel the grams. I want to be left with the ounces. So I'm going to put the 28 grams in the bottom and then the 1 ounce in the top. That way, these two things cancel, and the only unit I'm left with is ounces. And so now this time I have the 100 in the top, the 28 in the denominator. So I'm going to do 100 this time divided by 28, and that is 3.57 and a lot of change. I'm just going to round to 1 decimal place, and that is going to be 3.6 ounces approximately. All right, so that hopefully for you by this point in the course, in this unit, is review. Here is a little bit of new information about temperature. Okay, so we're going to talk briefly about that. So the US, where this course is based, when you're watching the news or you're looking on your phone at what tomorrow the weather is forecast, we predominantly use what's called the Fahrenheit scale. Now, because of some assumptions that Mr. Fahrenheit made about what he thought the coldest temperature was going to be and what he thought the human body temperature was, this scale came out for water freezing at 32 degrees and water boiling at 212 degrees. Those are kind of the common constraints. So when you're making your pasta or your rice on the stove and the water starts boiling, it is now 212 degrees in the Fahrenheit scale. And when you grab ice cubes out of the freezer, they are 32 degrees on the Fahrenheit scale. It's pretty interesting where this gentleman came up with all that. It's easy to Google it and look at what the background is there. So then, what in the metric system, What the metric system uses is called the Celsius scale. So if you've been out of the US for anything, then you've seen the Celsius scale. And again, like everything in the metric system, the Celsius scale is based on base 10. So the assumptions that they went in when Celsius invented this scale is he said, okay, I'm going to make the value that water freezes at 0 degrees and the value water boils at as 100 degrees. And so now it's all base 10 and everything is between that. So the relationship by these two scales, if you want to convert, if you start with Celsius, okay, so if you want to start with a Celsius temperature and convert to a Fahrenheit temperature, then you use Fahrenheit is equal to 9/5, or you can make that a decimal if you like, times the Celsius plus 32. Now, I would use this formula even if you're given the Fahrenheit and you're plugging it in there. I like to remember as few things as possible. And so I only have this formula remembered, and I just manipulate it if I need the other. Or what you can do if you like to remember more things is what we can do here is we can manipulate the formula. I can subtract 32 from both sides. And I say, okay, if I take the Fahrenheit minus 32, that gives me 9/5 times the Celsius. I want to get rid of this fraction. Okay, so this is some basic algebra. If you need help solving equations, send me an email. I have videos about solving basic equations. Okay, so I'm going to multiply both sides of this by 5. And so I have, I'm going to move over here because I did not allot myself enough space. Sorry about that. So I have 5 times the Fahrenheit minus 32 is equal to 9 times the Celsius. And I can now divide both sides by 9. And I can have the Celsius is equal to 5/9 and then parentheses F minus 32. There's my minus sign. So there's a minus sign right there. I'm sorry for my poor writing. I'm going to rewrite that up here in the box. So if I have the Celsius, that is equal to 5/9, the Fahrenheit minus 32. That's better, a little bit better penmanship right there. So you have those two formulas if you choose to remember both, or if you just choose to remember one and manipulate it. So I'm going to do an example, and then you're going to end with an exercise, and that's the end of this section right here. So if today's temperature is 90 degrees Fahrenheit, what would it be if we were using the Celsius scale? Remember, the temperature is the same. The scale we use is arbitrary. Okay, so it's kind of like when you're driving. If you're going 60 miles per hour, then that's the same as going 100 kilometers per hour. Doesn't mean 100 kilometers per hour does not mean you're going faster. It's just a different way of measuring using a different scale. Okay, so here we go. I'm going to use my one formula that I remember. So if it's 90 degrees Fahrenheit, that means I'm going to put 90 in for the F. And so then I have 9/5 C plus 32. Again, I choose to remember one formula. If you want to remember both and use this one right here, and then just do 90 minus 32, that is your prerogative. I have no problem with that. So now I'm going to subtract 32 from both sides of this. And 90 minus 32 is going to give me a grand total of 58. So I have 58 is equal to 9/5 C. I'm going to multiply both sides by 5. So 58 times 5 is going to be 290. 290 is equal to 9C. And then when I divide both sides by 9, I get that the Celsius temperature is equal. Oh, I need to write that. I'm dividing both sides by 9. The Celsius temperature is approximately 32.2 degrees, and the degree symbol is that little bubble. So you do the same thing. Exercise 7. I would like you to start. You woke up today, you were in London. It's 13 degrees Celsius, but you being and living in the United States, you've gotten used to using Fahrenheit temperature. So what is that in Fahrenheit? Okay, again, I hope you pushed pause. I hope you took time to do that problem. Again, that's how memory is built. And so I'm going to now take the 13 degrees. This time it's Celsius. So I'm going to put that in my formula. So I've got Fahrenheit is equal to 9/5. Oh, my pen is running out. Times 13 plus 32. And now this time, since I plugged in the Celsius, this is just a little order of operations problem. So I'm going to take the 9/5 and I'm going to multiply by 13. So we're going to clear this. So I've got 9 times 13 equals 117 divided by 5. And that is equal to 23.4 plus 32. So that morning when you woke up in London and it was 13 degrees Celsius, that is 55.4 degrees Fahrenheit. And that is a little bit cooler than maybe you were hoping or expecting. All right, so that is weight and temperature in the metric and the US system. And good luck on your homework. Let me know if you need anything.